We've all seen images of the nearby planets grouped together, often depicting the Sun as somewhat larger than Jupiter. However, this is not an accurate representation of the true scale. The Sun is so enormous that you could fit about 1,000 Jupiters inside it. As impressive as this is, our Sun isn't even the largest star in the universe, or in our galaxy. That title belongs to Ui Scorpii, and compared to it, our Sun appears as a tiny rock. But there's more. Scientists have accidentally discovered something even more astonishing: an ancient star with a black hole inside it. This galactic mystery both puzzles researchers and holds the potential to explain how the universe came to be. But how is it possible for a black hole to exist inside a star? Why were these stars so massive? And what would happen if a black hole star wandered into our solar system? Stars are like cosmic forges, creating most of the elements we see in the universe. The stars that might have existed at the very beginning of the universe, however, were different. Instead of ordinary stellar cores, they contained black holes within them, allowing them to grow to immense sizes, unlike normal stars. Stars form from clouds of gas and dust, where gravity causes the densest areas to collapse. The resulting mass heats up and forms a protostar, the earliest stage in a star's development. Eventually, this hot core accumulates enough material from the surrounding rotating gas disk to become a main sequence star, beginning nuclear fusion. Took our Sun around 50 million years to reach this stage. Most stars will spend the majority of their lives as main sequence stars, but eventually, they will either become white dwarfs if their mass is small, or explode as supernovae. The remnants of a supernova may become either a black hole or a neutron star, depending on the star's original mass. When our Sun runs out of hydrogen in about 5 billion years, it will expand into a red giant, growing up to 1,000 times its current size. Eventually, it will shed its outer layers and become a white dwarf, a dense object about 200,000 times denser than Earth but roughly the same size. Over the next 10 million years, the white dwarf will slowly cool, eventually becoming a cold remnant made of carbon and oxygen. Stars more than 10 times the mass of the Sun follow a different fate. They are massive enough for their cores to collapse after supernova, but they lack the mass needed to form a black hole. Instead, the extreme pressure inside these stars forces protons and electrons to merge, forming neutrons. This process creates a neutron star, which is the densest known object in the universe, aside from black holes. Despite being roughly the size of a city, around 12 miles (20 kilometers) in diameter, a neutron star can have the mass of the Sun. Neutron star material, as small as a sugar cube, would weigh about 1 billion tons, about as heavy as a mountain. So, how do stars become black holes? While the star is still active, two opposing forces are at work: nuclear fusion, which generates energy, and gravity, which tries to compress the star. When the star runs out of fuel for fusion, gravity wins, and the star collapses in on itself, much like the controlled demolition of a building. Einstein's theory suggested that anything could become a black hole if it had enough mass and was compressed into a small enough volume. Black holes continue to grow throughout their lifetime, consuming any material that comes too close. As they do, the region where the gravitational pull is so strong that nothing can escape, the event horizon, expands. Black holes have a limit on how fast they can grow, however, due to something known as the Eddington limit. Essentially, this is a point where a black hole can no longer absorb material faster than it already does. As matter spirals toward a black hole, it speeds up, and around 42% of it is converted into energy in the form of radiation. This radiation is so powerful that it can push some of the incoming material away, much like a tire's air escaping when overinflated. This process releases more energy than nuclear fusion in stars, potentially allowing us to harness this energy for our own needs. Some of the most massive black holes are located at the centers of galaxies, and recent discoveries show that some are far larger than we previously thought. One of the greatest mysteries in cosmology is how black holes at the centers of galaxies became so enormous, as their growth does not seem to be explained by the accumulation of matter over time. However, the discovery of black hole stars or semistars could be the key to solving this puzzle. These stars may have been the largest celestial bodies to ever exist, even outstripping the supermassive black holes we know of today. At the dawn of the universe, Space was filled with gigantic gas clouds. Within these dense regions, material collapsed under its own gravity, forming exceptionally large baby stars. These stars may have even originated from dark matter halos, mysterious regions of dark matter, perhaps as large as 100 million solar masses, that could have triggered the formation of these massive stars. Enormous stars, often referred to as supermassive stars, were not just exceptionally large but possessed a size that allowed them to absorb the catastrophic energy that would typically cause a star's outer layers to be expelled into space in a cosmic explosion. These ancient stars, however, didn't explode. Instead, they underwent a collapse, converting their central core into a small black hole while preserving their outer layers. If you were somehow able to observe this phenomenon up close, the star would appear unchanged. Once a small black hole forms at the heart of the star, it begins to consume the star from within. Though still small, the black hole starts to spin, creating an accretion disk of hot material orbiting it at nearly the speed of light. This disk, heated by friction, emits vast amounts of radiation, causing the star to glow brightly. These stars, which could have been massive, would eventually outshine even the largest known black holes and stars like Stephenson 228, Ui Scoy, and T618. The size of these stars could have ranged from thousands to millions of times the size of our Sun, potentially even as large as the entire solar system. However, the sheer size and mass of these stars come with a catch. The larger they became, the shorter their lifespan. While our Sun has existed for over 4 billion years and still has about 6 billion years left, these colossal stars lived only a few million years before they exploded with unimaginable force, creating an ever-hungry massive black hole that would drift across space, seeking more material to consume. Now, imagine if such a star ventured into our solar system. Its gravitational pull would disrupt the orbits of planets and celestial bodies, sending our once stable planetary system into chaos. Earth would face a barrage of asteroids, and as the star swallowed the outer planets, the temperature would rise dramatically, rendering Earth uninhabitable long before it was consumed. The central black holes within these stars may have even been the seeds of the supermassive black holes at the centers of galaxies today. The unique processes associated with these stars, such as the collapse of the black hole and its interaction with surrounding matter, could have been powerful sources of gravitational waves, potentially influencing the formation of cosmic structures and the distribution of stars within galaxies. Additionally, the intense radiation from these stars could have affected the habitability of planets in their vicinity, potentially creating conditions favorable for life, or destroying them altogether. Despite there being no known supermassive stars in the universe today, small primordial black holes, no larger than a rock, may still exist. Some physicists speculate that if such black holes were abundant, they could be wandering through space, occasionally getting trapped in gas clouds. As new stars are born, these early black holes would find their way to the star's core. Over just a few 100 million years, such black holes could grow significantly, even potentially forming a black hole as massive as the size of Pluto. One hypothesis, proposed by the late Stephen Hawking, suggested that if a black hole of Mercury's size were to enter our solar system, we wouldn't notice it, though this is highly unlikely. However, researchers believe there may be a way to detect these early black holes. One method involves looking for stars that behave differently than expected, specifically peddling stars, which are cooler than usual due to the presence of a small primordial black hole inside them. These stars would be significantly more durable and, as they evolve into red giants, they could exhibit peculiar vibrations. Scientists have already identified around 500 unusually cool red giant stars, and further study could reveal if any of them harbor early black holes. Some theories also propose that dark matter, the mysterious substance that makes up most of the universe's mass, could actually consist of a multitude of tiny primordial black holes. If this is true, then while it's unlikely that any one of these black holes would be caught by a star, the sheer number of them could make it inevitable that some would. Only time and further research will confirm this, but for now we must continue to explore the cosmos for more exciting discoveries and hidden truths. Stay tuned.